Hello and welcome to my Physics 2211 Lab Number 4 presentation about oscillations. So to introduce you to the lab's objectives, we're supposed to observe and analyze motion of a spring in 2 dimensions using tracker. We're going to create a computational model using Glowscript that predicts the motion of the spring, and then we're going to identify using the model data. So we have several relevant formulae that apply to this lab, and the fundamental principle is Newton's second law, which says that the motion of an object is in the direction of the net force, which is equal to the sum of all forces. And there are two forces at play: the spring force and the gravitational force. Thus, the net force is equal to the sum of those two forces. Some other important formulae are going to be the velocity update formula. The final velocity is equal to the initial velocity plus the net force divided by the mass times the time. The position update, where the final position is equal to the initial position plus the average velocity times the change in time. Spring potential energy, which is equal to half times the spring constant times the displacement squared. Kinetic energy, which is equal to 1/2 times mass times velocity squared. And then gravitational potential energy, which is equal to mass times gravity times height. And then we also have multiple initial conditions that we need to determine that's going to go into our Glowscript code. And most of these were determined using tracker or the pre-lecture video number 52. So the mass, that was 0.402 kilograms. The time of oscillations, that was determined from tracker. It was 9.40 seconds for 6.5 oscillations, giving an oscillation period of 1.446 seconds. Uh, K, which is the spring constant, was determined using a formula from the pre-lecture video, which is 4 times mass times pi squared divided by the time of the oscillation squared, which gave a spring constant of 7.59 newtons per meter. And then we had the relaxed spring length, which was also the formula was determined from the pre-lecture video number 52, which is equal to the spring length minus mass times gravity divided by the spring constant. Here we have Glowscript versus tracker data. So the data from tracker appears to somewhat match the Glowscript model. One issue that could explain the discrepancy could be the delta t. The data just seem to be more accurate as delta t decreases, but a smaller delta t means that the code takes even longer to run, and this code did take a significant amount of time to run. Another potential source of error could be the length of the calibration stick, which might not be the exact same from pre-lecture number 52 because it was a different video. So what does it mean? The main takeaway is that the energy principle is satisfied. Total energy is equal to the total change in energy is equal to the yellow line, and as you can see, it's pretty constant at 0. And another question in the what does it mean? The x versus y oscillation period. I had 6.5 oscillations in the x direction, which gave a 1.44 second time for oscillation. But then I had 6 oscillations in the y direction, which gave a 1.57 second time for oscillation. And because the time period for each oscillation is proportional to the spring constant, the spring force and the net force will have discrepancies depending on which oscillation period is used. So if this experiment were to be repeated, I might try to average the oscillation period in the x direction and the y direction to maybe 6.25, and maybe that would better match what's actually happening here, because the 6.5 oscillations give a quite different time from the 6 oscillation in the y direction. So that could be something that can be improved in a further experiment. Thank you for listening to my lab number 4.